So this is Expert Funda and you're watching on YouTube. So we simplify the data structure and algorithm for you. And so today we are going to solve a classic DSA problem, and we have given an array of integers in this problem, and to find the continuous subarray with the largest sum. So let's read the question. Question is saying that we have question number 53 of the Leetcode, and it is maximum subarray, where we have to find the given an integer array nums, and we have to find the subarray with the largest sum, and we have to return its sum. So the given example is we have here is the input nums. We have given an array where you have a couple of negative values as well as the positive integers we have given. So these are elements in this array, and so this is called integer array of the nums, and you will get the nums as an argument in the program, right? Because this is given. So we have to find the subarray with the largest sum, and we have to return its sum. Okay, so you can say the subarray sum will be have some value, and that value we have to return that contains the largest sum. If we'll sum of all the elements, let's suppose there will be multiple subarrays for this array, and one of the subarray is this. So if you sum these values, you will get the maximum value till now is 6. And so this example is very important to understand this example, okay, for this problem. Now understand the intuition of the Kadane algorithm in the steps and how we are going to tackle this problem, right? So the problem we have given is it's look like simple, right? So it's a very common interview questions, and including at FAANG companies, it has been asked by multiple times. Even you will, if you search for the Google interview question, you will find this question. Okay, so let's narrate the example quickly, right? So the example that we have seen having the maximum sum, and so we are going to use the intuition, and we will use the Kadane algorithm rather than using the brute force, because brute force will take off n square. It will cross out the time complexity, and so a brute force approach would check all the subarrays, and that will take off n square. But we can do better, and so in the interview you talk accordingly, because you can talk about the split, like you can talk about that the brute force will take off n square and anything, right? A lot of things you can take, but you can also tell that we have to check all the subarrays, and that is why we will not go for the n square, but we can do better. What we can do better? So we can use the Kadane algorithms, the code that we will see later, but first understand the intuition. So intuition is to meet the Kadane algorithm, the optimal solution will get for of n times, and we will not go for the brute force approach, because brute force approach will take of n square, multiple subarrays we have to go through. And so how it works? So Kadane algorithm will track the current subarray sum, and will name it as a current subarray, and at each step we'll decide, we'll start a new subarray from the current element. Okay, so we will keep track of the current subarray, and this subarray is called current subarray, or you can say we'll take any variables, right? And the maximum found so far is called max subarray. Okay, means current value will take, current sum of the window will take, and the max subarray of the window. So as well as the window is moving, right, we will get the subarray, but there will be the maximum subarray also value. So if we will get the maximum current subarray more than the max array, so the current subarray can update the max subarray. Okay, so at each step we will decide a new subarray from the current element, or will extend the existing one, and like that, and we'll keep a global max value. This is called global max array will take as a global max array variables, and as we go ahead, and we'll keep updating from the current subarray, right? So it looks like very simple, right? Efficient, and it will work in just one pass, so it will take off n times, right? So what if we try the divide and conquer approach, right? So if we will divide, we will use the divide and conquer approach, right? It will divide the array into two halves, right? And recursively we will find the max sub array on the left and right, and then it will calculate the maximum crossing sum across the midpoint. The result is the maximum of these three, but what will happen, it will take o log n, o of n log n, right? And but here the cadence algorithm will take o of n times, so it is better to write the cadence algorithm, right? So let's continue, right? So at each element, right, we'll take two variables, current subarray and max subarray, and at each element what we will do, we will decide if it is better to start fresh from the current subarray or continue the previous subarray, or we'll update the max subarray, right, maximum array, and if the current subarray is the best screen for so far till now, then we'll keep updating this one, or it will stay at that point, right? So you will understand this once we will get the coding, so you will understand this. Okay, so this greedy choice ensure linear tracking and linear traversal and tracking of the elements with no back steps, right? So first of all, what we will do, we'll create two variables, right, that will contain the current sum and the maximum, right? So we'll use to keep updating the value. Let's suppose I'm trying to say if a have some value, right? Let's suppose 10 we have, right? And then b contains 12. Okay, then if I want to swap this value, we can take third variables, right? Let's suppose temp, है? Then what we can do, if 10 can contains the a value, right, we can easily replace the value. We can put at b, we can put what, we can take 12 at a, right? We can write a equal to b, and then we can write v equal to temp, the swap thing, right? We can do that, right? And then we can replace the value. If you see the value here now, so a contains what, 12 now, and b contains 10 now, right? Like that, we'll create two variables and we can swap the value in the running you can say window. Okay, so for that, let's initialize the variables. Okay, so so first to do is initialize the current sum, right? Current sub array. Let's suppose it is, we will start from the first element of the array, right? Nums at 0. So we'll initialize like this, right? So what I can do, initialize the sub array, will do like this, and so I will define this current sub array, and we'll write this one. Okay, and also another variable we can take is max sub array, right? And this value we have to return, right? So we'll also write similar way. We can initialize the sub array from the first element of the array, right? So these two variables are required to swap the value in the current window. So this is the sliding window approach, and we are going to implement it. Okay, so this way we will write the to do to initialize the current sub and max sub array, right? Then we will make a loop. So we'll create a for loop, and we can slide the window from element second, right, of the array. So 0 we have already added, so we'll start with 1, and then we'll go to the last element of nums at length. So we can write like this, and I plus plus. So we are moving one by one to the last element, right? And for that, if we will take the elements at nums at I, we can get element, the number will get some element will get from it, right? And then what we will do, if this number we will use to add into the current subarray, let's suppose, right? So current subarray have some data, right? And we'll add this num, right? If we will add this num, we will get some value that is called sum, let's suppose. Okay, we can do that, right? Or you can directly write these two here, both is same, right? So I can remove from here, right? So now you are getting the sum from the current subarray plus num at I, right? You are getting some value, right? But why I have written the nums at I? Because I can reuse this one. Okay, so what I'm trying to say, if I will find the current sum. Let's suppose current sum I want to update each time. How? So I can take math dot max, and the current value is num, right? And then we can pass what? This value from here to here. We can write here, or we can remove this value, or we can write the sum. What is the sum? This is called current sum, because we are adding this value. So either you write complete value from here to here, or you can just write num, because we have already added, right? So the current sum you can add here, or the num. So better you write the one line code and you can remove this sum. Okay, so now you can see that the element, each element is called num. This num and the current sum plus this value, which one is max, that will go here in the current subarray, right? And so now once you have the current sub array in this loop, you can update the max subarray. So you have to do the same thing for the math dot max, and you can write what the current sub array, current sub array, and then the max element, right? You can write, or you can write this current sum and this, anywhere you can write here or there, but this looks good because sum array we are writing here, or it's already like, okay. So what, each time it will come and we can find the max sub array, which one is max, it will get updated, this one, and finally you can return max sub array. So let me run this program. Let me zoom out first. Yeah, as you can see, it is running. Okay, then I can submit this code. Working fine. Okay, so thank you guys, thank you for watching this video, and let me know the you can pause this video and just think about the complexity. Okay, so let's understand the complexity. Complexity is we are iterating over all the elements of the array, and we are calculating the current sum, current sub array, and then max sub array, and then we are returning the max sub array. Okay, so it will take of n times, and so the time complexity element, and there is we are not taking any extra spaces, so we'll take off one time. Thank you guys, thank you for watching this video. Let's continue further code, and let's understand the steps. So in the first step, what we have done, we have initialized the current subarray and max subarray with the first element, and so we will initialize these two variables and we will assign the value. Now we are making the loop, and the loop will contains a num value, and so we'll keep updating this num. Num is the element at the window of the window, right? So this will be the current subarray, and we are initializing from the nums at first element, so we'll update the next value, right? So the current value is the previous one and the current one, so we'll add this and we'll check with the current nums, right? If it is greater, we'll update the current subarray, right? It's like that the window will keep updating, keep expanding, the window will keep expanding, and so we will have the current subarray and the max subarray, and max subarray we are updating from the current subarray, which is max. The whenever the current subarray is getting greater, right, it will update the max subarray. Okay, and finally it will return the result that we have already talked about these things. So this is just a summary of this program, right? And it will take off n times as a complexity. Okay, so the thing that we are talking about is divide and conquer approach, also the intuition that we have thought in the steps, right? So it will, you can divide, you can split the array into two halves, you can conquer recursively by solving left and right halves, right? You have to combine the result again, you will calculate the max of array, and that will cross the midpoint, and you will return the maximum of left or right or and crossing sums, right? So, but it will take O of n log n, and so complexity is more, right, rather than the if you are comparing with the Kadane algorithm, right? So it is due to the recursive splitting and linear merges, and so it will take more complexity than the Kadane algorithm, so we will prefer Kadane algorithm. Okay, so if you'll talk about the implementation, right, so this implementation we have already seen, right? The cadence algorithm. Now if you want to go with the divide and conquer, just pause this video and go through this, where you will take a recursive function, and this recursive function will take you the elements left and right. So each time you will find the midpoint, right? You are discarding the first half, and you have to take other base case also, so it will not keep going there, right? You will find the left max and right max, which one is max, right? You will have the data, right? And if it is crossing the sum, right, max crossing sum, you will have the cross max. Now which one is max, right? Either this is max or this is max, you will return the final data. So another function is we have created max crossing function, and so max crossing function will find the max subarray sum that will cross the midpoint, right? So just go through the to do, you will understand very easily. It is not required to do that because it's not better approach, but if you want to understand the divide and conquer approach, just pause this video and try it yourself. If you have any doubt, please ping me in the comment box. Okay, so both solution give correct results, but the cadence algorithm is faster and it's better for the larger inputs, but divide and conquer is elegant but not practical for the competitive performance. And that's all for today, guys. Let me know in the comment about the video if you have learned something new, or if you want to keep continuing this playlist. Thank you for watching this video, guys.